Hi, welcome to the Olympiad geometry. Let's continue our study on Circumcenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. So here is a problem. Circle A meets circle B on CD, and both inscribed with circle O. MN are tangent. Line CD intersect circle O on P. PM, PN intersect circle A. PM intersects circle A on E. PN intersects circle B on F. Prove that EF is common tangent line of circle A and circle B. So in Chinese version of this problem, I actually used a very lengthy solution. That's the first solution I figured out, which is that we want to prove that EF is a common tangent of circle A and circle B, so we can just prove that EF is a tangent line of circle B. And then we can prove that EF is a tangent line of the circle A. To prove that EF is a tangent line of circle B, we can prove that angle EFD equals to angle DNF, which makes it to be a very lengthy solution. And when I prepare for the English version, I figured out a very simple solution, very elegant. I'm not sure if there's any other solutions that are better than this one, but this is best I can figure out. So let me show that. Okay, the first thing is that when we have this figure here, the first thing we can think about is to draw the tangent line, right? Otherwise, we cannot use a tangent point. So let's just draw the tangent line. Notice that the tangent line should be, so OBN should be collinear, and the tangent line is perpendicular with OBN, so I can just draw it like this. Okay? And for point M, we know that OAM are collinear, and the tangent line is perpendicular with OM, right? So just draw it like this. Okay, that's the first thing we do. And then we need to think about how to prove that EF is a common tangent line of circle A and circle B. Because of this problem is kind of symmetrical, so once we prove that, for example, F is a tangent point of circle B, EF is a tangent line of circle B, we can basically say that we prove another one, right? It's they're kind of symmetrical. So to prove that EF is a tangent line of circle B, we just need to connect BF and prove that BF is perpendicular with EF. Right, that's very easy to think of. So we want to prove that BF is perpendicular with EF, right? Prove this one. That's the target. And based on the figure, we know that PE times PM equals 2, PD times PC equals 2, PF times PN, right? From this, we got the triangle PEF is similar to triangle PNM, right? So we connect MN. right? Triangle PEF is similar to triangle PNM. Okay, now let's think about that. We want to prove BF is perpendicular with EF, which means we want to prove. So BF is perpendicular EF is equivalent to prove that angle PFE plus angle BFN equals to 90 degrees, right? So let's try to find if it's true. The angle PFE plus angle BFN can be rewritten as angle PMN plus angle BFN, right? And angle B, because BF equals to BN, so it equals to PMN plus angle BNF, right? And we know that angle PMN, because N is a tangent point, right? So let's call this point as whatever G here. So we know that angle PMN actually equals to angle PNG, right? So this one equals to angle PNG plus angle BNF. And we already know that BN is perpendicular with NG, so it equals to 90 degrees. That's it. We just prove that because of this is valid, so BF is perpendicular with EF. Then we know that EF is a tangent line of circle B, right? For this one, it's very similar. Think about that we want to prove. We want to prove that OE is perpendicular with EF. Right, so it's just a similar thing. I would leave this to the audience. Now, I want to talk a little bit about my first solution. It was a very lengthy solution, but I think it finds lots of interesting things behind it, right? So basically, we want to prove that angle EFD, right? That angle equals to angle DNF. Right? To do that, we need to think about what can we get from angle DNF. Right? So angle PNG equals to angle FDN equals to angle PMN. Right? So if we connect this out, we know that PC is a radical axis of circle A and circle B. GN is a radical axis of circle B and circle O. And this tangent line is a radical axis of circle O and circle A, which means these three lines are concurrent on a point, right? So just a hint, you might be interested to prove by yourself. Based on this one equals to this one, we want to find some, and actually see this equals to this angle, right? So we actually want to find some congruent or similar triangles to prove that this angle equals to this angle. Okay, I'll just leave it because it's too lengthy. I want to show this. This is the simplest solution. This problem is not a very easy problem if you don't use this way. I hope you like this video. See you in next one. Thank you.